Testing. Hello, Math 0092. We are continuing in this lecture with section 1.6. And before we begin content, I'd like to remind you that in addition to my recorded lectures, also at my math lab, under Multimedia Library in your left-hand navigational menu, you can choose the chapter, pick and choose, and we're working in chapter 1. And I just leave the sections, all sections, but you can also filter through the different sections in the book, such as we are beginning section 1.6. I'd like to look at videos that are available and click Find Now. And this is the way for you to navigate to each section's overall lecture and individual lectures and even some interactive participation with animation and such on particular sections in each chapter. Now, I'm reminding you of this again because it's important that you make use of these tools. Their lectures are available for each section in the chapters in the book. So it's worth your time to spend, again, reviewing the lecture material presented by other professional instructors. And I'd like you to take time to do that for all chapters that we cover in this book. So another media, a way to cover the material and the content with video lectures. So we'll continue now with section 1.6 on page 38. And on page 38, we're discussing rounding whole numbers. So the process of rounding a number. To round a number to a certain placeholder significance, locate the digit in that place of question. Consider the next digit to the right. If the digit to the right is 5 or higher, we're going to round up. If the digit to the right is 5 or lower, we round down. Change all digits to the right of the rounding location to 0. For example, round 6,485 to the nearest 10. So we have 6,485, and we're supposed to round to the nearest 10. The first thing we do is determine the placeholder that we're going to be rounding. So that would be the 10 placeholder. And then we need a little help. We're going to determine, are we going to round up or down? And we keep next door to the right. And inspect. If that is 5 or greater, we add 1 to our rounding location. If not, we place with trailing zeros. So 6,485 is approximately 648. I'm looking next door. It is 5 or greater. I'm going to add 1, so that'll be 9, and still remaining right with 0. 6,485 is approximately 6,490 rounded to 10. What if we round 6,485 to the 100? Well, again, mark or indicate the placeholder you're going to be rounding to. To round, we need to keep next door and determine, are we going to round up or round down? We need a little help. If it's 5 or greater, we're going to add 1. So that's 6, 5 to the placeholder that I'm rounding to, and fill trailing positions with 0. So 6,485 rounded to the 100 is approximately 6,500. 6,485 rounded to the 1,000 placeholder Indicator, mark your placeholder that you're rounding to. Keep next door for a little help. If it's 5 or greater, we're going to add 1. Otherwise, we fill with trailing 0. So 6,485 is approximately 6,000 rounded to the nearest 1,000. We might be asked to round 78,595 to the nearest tenth. Mark or indicate the placeholder you're going to round to. This is the question now. We need a little help. We're going to have to decide, are we going to round up or down? So we speak to the placeholder immediate right. If it's 5 or greater, we're going to add 1 to the placeholder that we're rounding to, and so we're trailing 0. This is 5, so we're going to add 1. 78, but 9 plus 1 is 10, so that adds 1 here, so I get 600. 78,595 rounded to the nearest 10 is approximately 78,600. Estimating. Estimating can be done in many ways. In general, an estimate rounded to the nearest 10 is more accurate than one rounded to the nearest 100. An estimated rounded value to the nearest 100 is more accurate than one rounded to the nearest 1,000, and so on. Purchasing a new vehicle. Jen is considering buying a new Ford truck. She has a budget of $35,000. Base price is $37,110. A number of options are available at additional cost. Some of these are listed in the following table. We have some of our optional features that can be added to the vehicle purchase. We're supposed to estimate by rounding to the nearest 100. Very important. It's giving us our direction. Estimate by rounding to the nearest 100 the cost of the Ford 150 XL, super cab option, the 5-liter V8 engine option, and the 4-wheel drive option, and off-road package. So we're looking at the super cab, the V8 engine, the 4-wheel drive option, and the off-road package. We have our original price, which is $27,110. The super cab option is $4,085. The V8 engine is $1,795. The 4-wheel drive option is $4,645. And the off-road package is $770. Now we're supposed to round to the nearest 100 our cost. So we're going to round 27,110 to the nearest hundred. Here's our placeholder next door, less than 5, so I have 27,100. Round 4,085 to the nearest hundred. 4,085, I'm going to round to the nearest hundred. I keep next door. It is 5 or greater, so I'm going to add 1 to approximate 4,000. Excuse me. We're going to round 1,795 to the nearest hundred. Keep next door. It is 5 or greater, so I'll round to 1,800. Round 4,645 to the nearest hundred. Keeping next door, it's less than 5, so I'll have 4,006 and fill with zeros. And round 770 to the nearest hundreds. Peaking next door, it is greater than 5, so I'll add 1 for 800. And now I can add my rounded values. And I get 38,400. So our estimated value is 38,400, and is that within her budget of 35,000? And our answer is the estimated cost is $38,400. This does exceed Jen's budget of 35,000, so she will need to have to forego at least one option, maybe more. Notice that we're stating our answer in sentence form, responding to the correct questions of the application scoring problem. We calculated the estimated total price at 38,400. This does exceed Jen's budget of 35,000, so she will have to forego at least one option, maybe more. Our next topic is order. We're comparing. Is a number greater than or less than another number? A sentence like x plus 5 equals, the thing is called an equation. The equation has the equal sign. We're equating one side of the equal sign to the other side of the equal sign. And that equation could be a true equation, or it could be a false equation. A sentence like 7 is less than 11 is called an inequality. It is not equal. It's a relation. The relationship of 7 to 11 is that 7 is less than 11. The sentence 7 is less than 11 is a true inequality. The sentence 23 is greater than 59 is a false inequality. So an equation equates with the equal sign. An inequality is a relationship with a relational inequality operator. Now our inequality symbols are less than means less than, greater than means greater than, and not equal to means is not equal to. And we have the equal sign with the slash through it. Looking at our number line for whole numbers, we have 0, 1, 2, 3, 4, 5, and it continues to infinity. We want to compare 5 and 2. So 2 compares how to 5? Well, 5 is to the right. 5 is to the right. And see my arrowhead? It's greater than. 5 is to the right of 2. So 2 is less than 5. For any whole numbers A and B, A is less than 5, read as A is less than B, is true when A is to the left of B on the number line. A is greater than B, read as A is greater than B, is true when A is to the right of B on the number line. So example 14, we're going to compare 7 to 11. 7 compares to 11. Well, on our number line, 7, and here's 11. 7 is to the left of 11, so 7 is less than 11. 92 compares to 87. "92 is to the right of 87. 92 is to the right of 87. So 92 is greater than 87. Looking at order and our relational inequality operators, greater than, less than, or not equal to. On page 44, we're asked to estimate each sum or difference by first rounding to the nearest hundred. We're going to estimate our sum or difference by first rounding to the nearest hundred. So number 38, we have 7348 plus 9247. We're just going to estimate this by first rounding to the nearest hundred. So that would be 7, 3, still with trailing zeros, to the nearest hundred, keep next door, and I'm going to fill with 0. And I can quickly add this 0, 0, 5. So my estimated sum, rounding to the nearest hundred, is 16,500. Example 36, we have 9,438 subtract 2,787. 9,438, and we're going to subtract 2,787. We're going to round to the nearest hundred. Keep next door, and that'll be 94 filled with zeros. Round to the nearest hundred. Keep next door. I'm going to round up, so that'll be 28. I can quickly subtract, borrow. 14, take away 8 is 6. 2 from 8 is 2. 4 is 6, I'm sorry. Is an estimated answer when we subtract, rounded to the nearest hundreds, of 6,600. We continue by estimating each product. Remember, product is our answer when we multiply by first rounding to the nearest 10. Your directions carefully. So I have 45 times 7. Rounding to the nearest 10. 10, I'm going to peek next door and I'll round to 50. 10, I'm going to peek next door and round to 70. And I can quickly multiply and get 0, 0, 35. So my estimated answer is 2,500. We're supposed to estimate each product by first rounding to the nearest 10. Number 48 is 63 times 54. round to the nearest 10. I'm going to peek next door, that'll be 60. Round to the nearest 10, peek next door will be 50. I'm multiplying. 60 times 50 would be 3,000. My estimated product is 3,000, rounded to the nearest 10. Next, we're looking at page 45 and our planning a vacation. Planning a trip to a theme park resort involves making lodging and dining decisions. The following table lists the prices of several options for a 3-day trip to a theme park resort. So our table is listing the prices for several options for a 3-day trip to a resort. Number 62. Estimate the total price of a 3-day trip with a family value hotel, a theme park ticket, and a fast food meal plan. Round each price to the nearest $100. So our table is representing prices for a 3-day trip. We want a family value hotel. So that's our first option for $498. We want a theme park ticket of $289. And we want a fast food meal plan of $145. Now we've captured our X pricing from the table presented. We want to round each price to the nearest 100. We're going to round to the nearest 100. Find your placeholder, peek next door. 5 or greater, we round up. Nearest 100, we're going to find our placeholder, peek next door. If it's 5 or greater, we round up. Find your placeholder, peek next door. If it's 5 or greater, we round up. Otherwise, we fill with zeros. And now we can add 500 plus 300 would be 800 plus 1 would be $900. So the estimated total price of our selected options for a 3-day resort trip, rounded to the nearest 100, is $900. On page 46, number 69, we're looking at banquet attendance. Tickets to the annual award banquet for the Penn Club cost $28 each. Ticket sales for the banquet total $2,716. Estimate the number of people who attended the banquet by rounding the cost of the ticket to the nearest 10 and the total sales to the nearest 100. Well, the cost of our ticket was $28 and the total sales was $27,016. We're supposed to round our ticket to the nearest 10. 10, peek next door would be 30. And round the total sales to the nearest 100. There's 100 peek next door, so we'll fill with trailing zero. Now we want to estimate the number of people who attended the banquet. Each purchased a $28 ticket. So we have approximately a $30 ticket goes into the approximated sales of 2,700. 2,700 divided by the total sales divided by the total ticket price, 90. So we are estimating that 90 people attended the swim club annual awards banquet. On page 47, post-secondary education. The number of degrees awarded by post-secondary institutions in the United States in 2014 to 2015 has been shown in the table below. Use this table to complete exercises 83 and 84. So, number 484, write an inequality to compare the number of associate degrees and master's degrees. So we want to compare associate degrees to master's degrees. Our associate degrees, 1,014,023. Compared to master's degrees, the master degrees are 758,708. So comparing, 1 million is greater than 700,000. So associate degrees were greater than master degrees throughout the years 2014, 2015. Annual species. The number of species for categories of vertebrate animals is shown in the following figure. Write an inequality to compare the number of species of birds and the number of species of reptiles. So from the chart, we want to read the labels vertically. We have mammals, and the bar chart is indicating 5,513. Birds, quantity is 10,425. Reptiles, quantity is 10,038, and so on. We're moving across the chart to locate that total number, counting by 5,000, 10,000, 15,000, 20,000, 25,000, 30,000 on the tick marks on the horizontal axis. Now we're supposed to compare birds count to reptile count. The birds total is 10,425. Compared to reptiles, reading my chart, reptiles, and I'm picking up 10,038. 10,425 is greater than 10,038. So I'll use my greater than symbol to represent the relationship of the number of species of birds compared to the number of reptiles. We then start on page 49, the section 1.7. And we're going to begin solving equations. So solving an equation, x plus a equals b. To solve x plus a equals b, subtract a on both sides. So we're told that x plus a equals b as an equation. If I want to solve for x, then I want to isolate x. My goal is to be able to say x equals. So my goal is to get the desired variable on one side of the equal sign all by itself. Now, if we're supposed to solve for x, and I have x plus a equals b, so I have x, my variable, plus something is equal to b. I want to get x on one side of the equal sign all by itself. I know that if I add the opposite of a, by subtracting a from both sides. If I subtract a from a, I'm going to get 0. And x plus 0 equals, and now I'm just going to type up this equation. I have b subtract a. Well, x plus 0 is x itself equals b minus a. So in order to solve for x, when I have x plus something equals something, if I can subtract a's value from one side of the equation, I'll have to subtract the same thing from the other side of the equation to keep my pendulum balanced. But I've isolated x, and now I have solved for x. X equals b minus a. Let's try a couple of examples. If I have t plus 28 equals 54, my goal is t equals. My variable is t. I want to isolate t and get it on one side of the equation so I can say that t equals. But we just learned that we can get rid of this term by subtracting it from both sides. 28 plus the 28 subtracting 28 is 0. And t plus 0 is t equals. So I'm getting pretty close to the goal. But I have to tidy up this side of the equation. And if I have 54 and subtract 28, I get 26. 54 subtract 28 is 26, which says t equals 26. Now we'd like to check this. We started out with t plus 28 equals 54. And I just said that t is equal to 26, so I'm going to substitute 26 for every occurrence of t, copy everything else down the same. (26 plus 28) is equal to 54. That is a true statement, so I can circle my answer. Example 6 on page 50. We have 182 equals 65 plus n. Well, in this case, the variable is n. So my goal will be n equals. I want to be able to say and solve for n. So n equals is my goal. Now I have n plus a little bit. If I subtract 65 from both sides of the equation to keep my pendulum balanced, I'm subtracting 65 from 65, which is 0. And that equals 0 plus n is n. So I'm getting close. I have n equals on one side of the equation. And then on the other side of the equation, I need to tidy this up a little bit. 182 subtract 65 is 117. Now 117 equals n, or n equals 117. Both are the same. Equals are equal to equals. But we should check our answer. We had 182 equals 65 plus n. I'm going to substitute my value, which I'm saying is 117, for every occurrence of n. And 65 plus 117 is 182. That is true, so I can circle my answer. On page 51, we have another solving equation. A times x equals b. To solve a times x equals b, divide both sides of your equation by a. We have a times x equals b. Now, if something times x, my goal again is x equals. I'm solving for x. If I divide a by a, any number divided by itself is equal to 1. Remember, we can't divide by 0, but otherwise, any number divided by itself is equal to 1. So I have another name for 1 here. And 1 times x would be x equals. I'm getting pretty close to my goal. But if I divide one side of the equation by a, I'm going to have to divide the other side of the equation by a. So now I have x equals b over a. So x times a is equal to b. When solved, is x equals b over a. Let's try an example. We're supposed to solve 10 times x equals 240. Well, my goal is x equals. So I want to isolate the variable, but it's tied up in multiplication. 10 times x. If I divide 10 by 10, I have another name for 1. 10 divided by 10 is another name for 1, and 1 times x is x equals. I'm getting close to my goal. But if, because of some strategy, I have to divide this side of the equation by 10, I'll have to divide this side of the equation by 10 as well to maintain my equality, to keep my pendulum balanced. And 240 divided by 10 is 24. So let's check. We had 10 times x equals 240. I'm going to substitute my answer for recurrence of x. 10 times 24 is 240. And 10 times 24 is 240, equals 240. That is true, so I can circle my answer. Page 51, example 9, 5,202 equals 9 times t. We're supposed to solve. So my goal is, in this case, my variable is t, so I want to isolate t and be able to say t equals. This is, t is tied up in multiplication, so if I divide 9t by 9, 9 over 9 is, again, another for 1. 1 times t leaves 3. But if I divide one side of the equation by 9, I'll have to divide the other side of the equation by 9. Leaves 578. Now we're going to want to check. We have 5,202 equals 9 times t. I'm going to substitute my answer for every occurrence of t. My answer was 578. 9 times 578 is 5,202. That is a true statement, so I can circle my answer. You're given 438 plus x equals 807. You're supposed to solve this equation, which means solve for the variable, and our variable in this case is x. So we're going to set our goal as x equals. I want to be able to solve saying that x equals to end in a true statement. Well, here I'm adding. So if I subtract 438 from 438, that goes to 0. And 0 plus x is x equals close to my goal. But if I subtract something from this side of the equation, I have to subtract the same thing from the other side of the equation to keep my pendulum balanced. So 807 subtract 438 is 369. Of course, we want to check this. We have 438 plus that equals 807. I'm going to substitute my answer, which is 369, for every occurrence of x. Four, 3, 8 plus 3, 369 is equal to 807. 807 equals 807. So I can circle my answer. 40 times x equals 1800. We're supposed to solve this equation, which means solve for the variable. So our goal is x equals in this case. This is multiplication. Since it's 40 times x, I know that if I divide 40 by 40, I'll have another name for 1. 1 times x is x equals. But if I divide one side of the equation by 40, I'm going to have to divide the other side of the equation by 40 to maintain the equivalency. So I have 1800 divided by 40 is 45. X equals 45. And checking, I have 40 times x equals 1800. I'm going to substitute my answer, which is 45, for every occurrence of x. Copy everything else down the same. 40 times 45 is 1800. That's a true statement, so I can circle my answer. Next, we begin section 1.8. And we have some important ways in which we use mathematics as a tool to solve problems. And we want to begin to apply our 5 steps for problem solving. So we're looking at some story problems now, and how do we begin to approach the process of solving a story problem. So these are the steps that you want to keep handy as you begin to work with story problems. First, we familiarize ourselves with the problem situation. Then we translate the problem to an equation or a math model or an expression. We solve that equation. We be sure to check our solutions to see if they actually seem to fit an estimate or make sense. And then we state the answer clearly in a complete sentence, making sure that we label units. To familiarize ourselves, if the problem is a word problem or a story problem, read it and then read it again before you start doing anything. Read the problem first, the whole story problem, and then reread it. It's amazing, but your brain will begin to work and solve that problem as you reread it. So it's just allowing yourself to take a little bit of time to approach the problem. And then we want to sketch or draw. We want to begin to label some of the facts that Write the list of known facts or itemize or label in your chart or diagram. Assign a variable as needed to any unknown value. Organize again in your chart, in your table, your diagram. You may need to look up formulas, consult a reference book, double check formulas in our textbook, maybe check with a tutor, and then be sure to estimate. Does your answer estimate to a reasonable solution? On page 55, we look at our first application problem. The following table shows the number of games released for each popular video game platform as of 2017. 3 of these platforms are made by PlayStation. Find the total number of games released for the PlayStation platform. So here's our platform, Nintendo, Xbox, PlayStation. Here's the number of games that we have. Well, we're interested in PlayStation. PlayStation 2, PlayStation 3, and the original PlayStation. So the number of games that we have is PlayStation, the original, 2, and 3. Now we're looking for the total, find the total number of games. So we're going to pick up PlayStation 2 with 3,549, plus PlayStation 3 is 3,313, plus PlayStation, the original, is 2,680. So I'm going to adding, I get 3,549 plus 3,315 plus 2,680, and I get 9,544. Now we can check this by estimating, maybe rounding to the nearest 100, rounding to the nearest 1,000, get a quick estimate. But we needed to add each individual number of games sold per PlayStation type to get the grand total of the number of games released for the PlayStation platform. Now we're going to state our answer. It's a story problem, an application problem. We're going to state our answer in full descriptive sentence form. The total number of games released for the 3 PlayStation platforms is 9,544. On page 56, our next story problem. Travel distance. Abigail was driving from Indianapolis to Salt Lake City to attend a family reunion. The distance from Indianapolis to Salt Lake City is 1,634 miles. In the first 2 days, she traveled 1,154 miles to Denver. How much farther must she travel? So we see our map on page 56. She's leaving Indianapolis, but she has traveled as far as Denver, which is 1,154 miles. And she wants to travel to Salt Lake City. The distance from Indianapolis to Salt Lake City is 1,634 miles. So the distance that she's already traveled, 1,154 miles, plus the distance we don't know from Denver to Salt Lake City, needs to equal the total trip, which is 1,634. So she has traveled, will travel, for total trip. Well, we want to solve for the distance remaining that she needs to travel. So our goal is to solve for D. equals. You want to isolate the variable. I'm adding, so D plus a little bit. If I subtract that amount, 1,154 subtract 1,154 goes to 0. 0 plus 3 is D equals. But if I subtract 1,154 from one side of the equation, I have to do the same thing to the other side of the equation. That keeps my pendulum balanced, keeps my equal sign, my equation remains true. So I'm going to tidy up this side of the equation. I have D equals, but now I need to subtract 1,654 subtract 1,154, and I end up with 480. And D stands for distance in this case. So the distance remaining is 480 miles. And now we're going to state our final answer. Abigail must travel 480 miles farther to continue her trip to Salt Lake City. Okay, on page 57, example 3, total cost of chairs. What is the total cost of 6 chairs if each one costs $169? Well, we can familiarize ourselves with this. We have 1, 2, 3, 4, 5, 6 chairs, and each one $169. So we can multiply 6 times the cost of each chair to determine the cost. So I have 6 times $169 equals my cost. 6 times 169 is 1,014. So the cost of 6 chairs, each costing $169, is $1,014. We're going to state our answer. The total cost of 6 chairs is $1,014 in full descriptive sentence form. Our next story problem, or application problem, the area of an oriental rug. The dimensions of an oriental rug placed in the foster's front hallway are 42 inches by 66 inches. What is the area of the rug? The area of the rug. Now remember, this is a rectangular looking rug. I've kind of sketched a rug pattern, rectangular, 42 inches by 66 inches. Now you have to remember that area of a rectangle is equal to the length times the width. And I could look that up. We've already discussed that earlier in this chapter. Or check with your tutor, look it up on the internet, how to calculate the area of a rectangular object. And so our rug is given to us as 42 inches wide and 66 inches long. So the area of this rug will be the length is 66 inches times 42 inches. Now remember the commutative law for multiplication. 3 times 4 is the same as 4 times 3. 12 equals 12. Our terms can commute as long as it's all multiplication. So I'm going to group my constants together and my unit measurements together. And 66 times 42 is equal to 2,772. And inches times inches is square. We always must label our units within our story problems. So take care and remind yourself, we're working with a special story problem, a special application, so units have meaning. If we're just working with equations and no references to unit measurements, then there is no unit to label. Now this is a story problem, so we need to state our answer in full descriptive sentence form. The area of the rug is 2,772 square. Continuing, we have example 5 on page 58. A candy company produces 3,304 sticks of gum. How many 12 packs can be filled? And how many sticks are left over? So we have 3,304 sticks of gum and we want to package them. Each package is to have 12 sticks. So we need to divide our total number, 3,304, by 12. $3,304, and we're going to divide by 12. Because we want to place these total pieces into 12 piece packages. So 12 goes into 3,304 how many times? Well, I'm going to get out my calculator. 3,304 divided by 12, and I get 275 plus a little bit, 0.33. I know there's a remainder. It does not go in 3,304 evenly. But I do know the whole number, 275. So I can figure out my remainder. 275 times the divisor, 12. 275 times the divisor, 12, is 3,300. Now that's getting close to my dividend. I'm going to find the difference. 3,304 minus how much do I have so far? 3,300. Finding the remainder, I have a remainder of 4. So 3,304 pieces of gum can be packaged into 12-piece packages. I'll end up with 275 packages, 12 pieces each, with a remainder of 4 sticks of gum. Now again, we state our final answer in full descriptive sentence form. Thus, 275 12-pack packages of gum can be filled. There will be 4 sticks left over. Our next story problem or application problem is automobile mileage. A 2017 Honda Accord Sport gets 26 miles per gallon MPG. Miles per gallon is abbreviated in city driving. How many miles will it use in a 4,758 mile trip, all of city driving? Well, I can kind of familiarize myself with this. I know that for 26 miles, I use a gallon. 26 miles, I use a gallon. 26 miles, I use another gallon. I'm going to drive 4,758 miles. I want to divide my 4,758 miles into kind of equal portions of 26. So how many portions of 26 will I need? 26 miles per gallon, how many gallons am I going to need? So 26 for every gallon, I can drive 26 miles. When will that equal 4,700? Well, I'm trying to set a goal now to isolate the number of gallons. G is the variable I chose. I'm multiplying 26 times the number of gallons is 4,760. I want G on one side of the equation all by itself. So if I divide this side of the equation by 26, I'm doing that because my strategy is 26 divided by 26 goes to 1. 1 times G would be G equals, which is very close to my goal. But if I divide one side of the equation by 26, I'm going to need to divide the other side of the equation by 26. So I have 4,758 divided by 12. That'll be equal to 396. I think I better try again. 4,058 divided by 26 is 183. That looks better. So the gallons used was 123 gallons to travel 4,758 miles, knowing that I'm going to get about 26 miles per gallon. The 2017 Honda Accord Sport will use 183 gallons of gasoline as we state our final answer in full descriptive sentence form. On page 60, there are times that we might have to do multiple operations to solve a problem. And we might call this a multi-step problem. Example 7, weight loss. To lose 1 pound, you must burn about 3,500 calories, in excess of what you already burn during your regular daily activities. The following chart shows how long a person must engage in several types of exercise in order to burn 100 calories. For how long would a person have to run at a brisk pace in order to lose 1 pound? Well, our chart shows us that in order to burn 100 calories, you must, if you choose running, run for 8 minutes at a brisk pace. To burn 100 calories, you must swim for 2 minutes at a brisk pace. To burn 100 calories, you must do aerobic exercises for 15 minutes, and so on. We've itemized running, swimming, bicycling, aerobic exercises, golf, and playing tennis. But our chart is indicating to burn 100 calories, we have to do this activity for a certain amount of time. In order to lose 1 pound, you must burn about 3,500 calories in excess of your normal activity. So we need to know how many 100s are in 3,500 calories to burn that 1 pound. So 3,500 divided by 100 equals 35. So the number of hundreds times the activity that we choose. And we are to find how long would a person have to run at a brisk pace in order to lose 1 pound. So to run, it takes 8 minutes. That's running to burn 1 pound. So I have 35 times 8. 35 times 8 is 280. So stating my final answer, you must run for 280 minutes at a brisk pace in order to lose 1 pound. Now, 280 minutes, they say, is 4 hours and 40 minutes. We can just get that here. There's 60 minutes in an hour. 60 goes into how many? 280 minutes, how many times? 280 divided by 60 I get 4 plus a little bit. 4. 4 times 60 would be 240. Subtract off, find 40, so my remainder is 40. So 280 minutes is 4 hours and 40 minutes. So converting minutes to hours and minutes. Now, you want to spend some time in your ebook on page 61 because we're looking at keywords, phrases, and concepts. We want to acquaint ourselves with these keywords that mean the operation of addition in our story problem. Keywords that tell us to use subtraction in our story problem. Keywords that tell us that the operation we're going to be using in our expression or equation to solve this story problem, we're going to use multiplication. And keywords that indicate division. So in addition, some keywords are add, added to, sum of course, total, plus, more than, increased by. Subtraction keywords are subtract, subtracted from, difference of course, minus, less than, decreased by. Multiplication, well, of course, multiply by, product, times, of. Keep that in mind. Of represents the operation of multiplication. Division is indicated by the word divide, divided by, quotient of course, missing factor, find equal quantity, equal parts of a whole. And then finally, problem solving tips. Always look for patterns when you're solving problems. When translating to mathematics from a word problem, consider the dimensions of the variables and the constants in the equation. The variables that represent length should be all in the same unit. Variables that represent money should be in all dollars or in all cents, and so on. Make sure that your units are equivalent. Make sure that units appear in your answer as you're stating the final answer. Make sure that your labeling is complete. On page 64, number 11. A high-definition TV, HDTV, screen consists of a small rectangular dot called pixels. How many pixels are there on a screen that has 1,080 rows with 1,920 pixels per row? So we have 1,080 rows times the number of pixels in each row, which is 1,920. 1,080 times 1,920 equals 2,073,600. I'm going to label that pixel. So the total number of pixels on an HDTV screen that has 1,080 rows with 1,920 pixels per row is 2,073,600 pixels. On page 65, housing costs. The graph below states the average monthly rent for a one-bedroom apartment in several different cities during June of 2017. You're supposed to use the graph to answer question 1722. While familiarizing ourselves with the graph, we have the average rent for a one-bedroom apartment. We are 500, 1,000, 1,500, 2,000, 2,500 increments by 500 represent the rent per month. And then we have cities of Indianapolis, Phoenix, Dallas, Atlanta, and Seattle. So number 17. How much higher is the average monthly rent in Seattle than Dallas? Well, the rent in Seattle is $2,063. And I'm looking for the difference when I compare to the rent in Dallas, which is $1,064. Find the difference, which indicates the operation of subtraction. Now, this is on page 65 in your ebook, because the graphic is kind of hard to read with the dark background and black print. 2,063 minus 1,064. We're finding the difference in the average monthly rent of a one-bedroom apartment in Seattle compared to Dallas is $999 per month. $19. Phil, Scott, and Julio plan to rent a one-bedroom apartment in Atlanta immediately after graduation, sharing the rent equally. What average monthly rent can each of them expect to pay? Well, actually, they're going to be renting a one-bedroom apartment in Atlanta. So let's find Atlanta. Its monthly rent is $1,401. And they're going to be dividing that by 3. So 3 goes into 1,401. 467 times. So $467 per month is what each of them can expect to pay. On average, how much rent would a tenant pay for a one-bedroom apartment in Phoenix during a 12-month period? So let's find Phoenix, and that's $936 per month. So for a 12-month period, they'd be paying for 12 months. So $936 monthly rate times 12 is $11,232. $11,232. Number 23, before establishment of the U.S. Census in 1790, it was estimated that the colonial population in 1780 was 2,780,400. This was an increase of 2,628,900 from the population in 1680. What was the colonial population in 1680? Well, we know that in 1780, the population was 2,780,400. Now, it was estimated that the colonial population in 1780 was 2,780,400, which was an increase. So that's more than what was in 1680. We're going to subtract 2,628,900. And that will give us the population of 1680. $2,780,400 minus 2,628,900, and we end up with 151,500. Which was the population in 1680. So the colonial population in 1680 was 151,500, and it increased by 2,628,900 to a total of 2,780,400 in 1780. Refrigerator purchase. A deli has a chain of 24 restaurants. that buys a commercial refrigerator for each store at a cost of $1,019 each. Determine the total cost of the purchase. We're going to buy 24 refrigerators at $1,019. Paper measures. We're on page 66. A quire of paper consists of 25 sheets, and a ream of paper consists of 500 sheets. How many quires are in a ream? So 25 sheets goes into 500 sheets. How many times? And we'll end up with 20 quires. On page 67, a Ford Focus with a manual transmission gets 30 miles per gallon. That's PG again, miles per gallon, in city driving. How many gallons will it use in 7,080 miles of city driving? So 30 miles goes into 7,080 miles. How many times? 236. The high school court. The standard basketball court used by high school players has dimensions of 50 feet by 84. This is 50 feet by 84 feet. What is the total area? So part A. Part A, we are trying to solve for area. We know that area of a rectangular region is equal to the length times the width. So area is equal to 84 feet times 50 feet. The area is equal to 84 times 50 times feet times feet. Area is equal to 84 times 50 is 4,200. And we have to label. Remember that we are multiplying, so it's feet times feet, which is square feet. Part B. What is the perimeter? Remember, the perimeter is the distance all the way around your object. We want to put up a fence to keep the rabbits out of your garden. So starting and being consistent, 84 feet plus 50 feet plus 84 feet plus 50 feet. We can add 84 plus 50 plus 84 plus 50 is 268 feet. So the perimeter is equal to 268, and we're just adding feet plus 2 feet plus more feet. So our unit measurement is in. Map drawing. A map has a scale of 215 miles to 1 inch. How far apart in reality are two cities that are 3 inches apart on the map? That's part A. So part A, if they're 3 inches apart and every inch equals 215 miles, then 3 times 215 is 645 miles. So if the two cities are 3 inches apart on the map, it's actually 645 miles distance between them. And part B, always look for multiple questions in your story problem. How far apart on the map are two cities that, in reality, are 1,075 miles apart? Well, we know that every inch represents 215 miles. So if we divide 1,075 by 215, that would represent 5 inches. Okay, then we begin with section 1.9, Again, remember that there are section videos for each section of the book. In section 1.9, we're introducing exponents. 10 squared means the base times itself. How many times? Base times itself 2 times, which is 100. 10 cubed would be the base times itself. How many times? 10 times 10 times 10 is 1,000. 3 squared would be the base 3 times itself. How many times? I'm raising my voice because that's a superscript. It goes up. Superscript. 3 times 3 is 9. 3 cubed would be the base times itself. How many times? 3 times. 3 times 3 is 9 times 2 is 27. How about 4 to the 4th? Well, we can use our calculators now to help us. I have 4. I'm looking for the caret symbol. The caret symbol. It looks like kind of a little teepee. Caret symbol to the 4th. 4 raised to the 4th is 256. Means the base times itself 4 times. Now on our calculators, we're going to type the base. The symbol is called the caret symbol. 4 raised to the 4th power is equal to 6. Remembering that exponents are a shortcut for multiplication. The shortcut is that the base times itself a given number of times. The base times itself a given number of times. So exponents, we have a base raised to a power. And it's the base times itself. How many times? So now we can introduce our rules for order of operations on page 71. Very important page, very important rules. Your calculator, device, Google Calc, obey these rules. Number 1, do all calculations within parentheses or brackets or braces before operations outside. So do all calculations within parentheses first. Evaluate all exponent expressions next. Then do all multiplications and divisions in order from left to right. And do all additions and subtractions in order from left to right. Now you may have heard of this as please excuse my dear Aunt Sally. Or some people say PEMDAS. Please excuse my dear Aunt Sally. So let's notice what happens. This is on page 71. 16 divided by 8 times 2. So I'm just going to sketch, please excuse my dear Aunt Sally. There are no parentheses. There are no exponents, but I do have multiplication and division. But I will do multiplication and division from left to right. So I have 16 divided by 8. I'm going to solve that. That'll be 2 and copy everything else down the same. I don't have any more division. I have multiplication. 2 times 2 is 4, and I have solved the problem. On page 72, 7 times 14 minus, in parentheses, 12 subtract, or 12 plus 18. Copy down my cheat sheet. Please excuse my dear Aunt Sally. I have parentheses, so I have to operate within parentheses first. Following, please excuse my dear Aunt Sally. There's no parentheses, no more parentheses, no exponents, multiplications up to 8. So I'm going to same, and do not hesitate to do this. It's very important that we do one step at a time. Even though your calculator can do this rapidly and computers can work in nanoseconds, we have to practice abiding by the rules of precedence and working one step at a time. Just as your calculator does, except it does work one step at a time according to these rules, but much faster. So in parentheses, we have 12 plus 18. I can solve that. Copy everything else on the same. Subtract, and there's nothing more to simplify here, so I can remove those parentheses. Now looking at my expression, there's no parentheses, there's no more exponents. I do have multiplication, so I'll have to do multiplication from left to right. This is 7 times 14, and 7 times 14 is 98. Copy everything else down the same. There's no more multiplication or division, but I do have subtraction. So I'm going to subtract 30 from 98 and get 68. Solving this problem in any other manner would be incorrect. So we must memorize and follow PEMDAS, or please excuse my dear Aunt Sally, explicitly. This is example 7 on page 72. 23 subtract, in parentheses, 10 subtract 9. Again, I have multiple operators with parentheses, so please excuse my dear Aunt Sally. I'm just going to copy down my little cheat sheet. And I have 23 minus in parentheses, 10 subtract 9, only 1. Copy everything else down the same. I'm going to simplify 1 in parentheses. I wouldn't use the parentheses anymore. And 23 subtract 1 is 22. Now let's just compare. If I have 23 subtract 10 in parentheses, minus 9. Please excuse my dear Aunt Sally. I'm going to look in parentheses first, and I'll get 13 minus 9. 13 in parentheses is a constant. I can remove the parentheses, copy everything else down the same to simplify. And 13 subtract 9 is 4. So we see that even though 23 minus 10 minus 9, 23 minus 10 minus 9 is the expression, the parentheses establishing a different result, which tells us that subtraction is not associative. I cannot just regroup in subtraction and get the same result. Subtraction is not associative. Example 10. 4 squared divided by, in parentheses, 10 minus 9 plus 1, the quantity q times 3 minus 5. I'm going to copy my sheet down. Please excuse my dear Aunt Sally. So I'm solving this problem according to our rules of operator precedence. We're going to do exponents first. 4 squared would be 4 times 4, which is 16, divided by, in parentheses, I have 10 minus 9 would be 1 plus 1 is 2, times 3 minus 5, 2 cubed. Now, I still have parentheses, and it is an exponent, so I have 16 divided by 2 cubed is 2 times 2 is 4 times 2 is 8, times 3 minus 5. Copy everything else down the same. And work down your page, not across, to eliminate possible mistakes. Always solve one thing at a time and work down. So now I'm looking at multiplication and division. Here's division from left to right. First thing I come upon is division before multiplication. So 16 divided by 8 is 2 times 3 minus 5. I still have multiplication. 2 times 3 is 6 minus 5. I'm ready to subtract 6. Subtract 5 is 1. So always use the rules of precedence. Copy down your cheat sheet. Please excuse my do not tally, and reference it as you're solving problems one step at a time, working down your page. On page 73, we introduce the average. The calculation of an average. The average of a set of numbers is the sum of the numbers divided by the number of addends. So first, we have to sum the data items, and then divide that result by the count of the data items. So this is a two-step process. The national parks. Since 2000, 4 national parks have been established in the United States. The sizes of these parks are known in the figure below. Determine the average size of the 4 parks. We'll determine the average. We add the data items first and then divide by the count. So we're going to add first. 33,000 acres plus 24,180 acres plus 149,140 plus 26,000. Parentheses, we have to add first, and then we're going to divide by the count of our data items, 1, 2, 3, 4. So adding 33,000 plus 24,180 plus 149,140 plus 26,000 is equal to 232,320. $232,320 divided by 4. So now I have to divide by the count, and I get 58,080. So the average size of the 4 parts is 58,080. Stating in full sentence form, the average size of the 4 national parks is 58,080 acres. With average, remember that calculate the average. Step 1, add data items first, then divide by the count of the data item. All right, this completes our lecture of Chapter 1 content. I will have one more lecture where we will review for your Chapter 1 unit test. In the meantime, please return to D2L Brightspace for all details regarding homework, assignments, tests, and their due dates. And thank you very much.